Okay, sorry for that one. Let me start properly now. They say the product of the net force acting on an object, in this case net force acting on an object, and the time taken, and time taken while in contact or while the force acts. Very simple. 1.3, let's move. We are in 1.3 now. 1.3, they say to us, calculate the magnitude of the net force acting on the denser length. Calculate the magnitude of the net force. Now, remember, there's only one formula in this section of momentum that deals with the net force. F net delta T will be as change in momentum. We are calculating the net force. The time is given. Change in momentum. This was the initial momentum. The final, because it comes to a stoppage, then the final momentum will be 0. And the initial is 250. Therefore, the answer now, the F net will be negative 1250 newtons. But now, because force is a vector, we cannot leave it with negative. Then we'll say, therefore, the F net is going to be 1250 Newton, because I was going down, therefore it will be now, this will be upwards. So we're taking downward as positive here. This will be upwards now. Very easy. Let's do the last two questions. Now the next question says, okay, fine. Now it's explanation time. They say to us, assume that the dancer performs the same jump as before, but lands without bending the knees, her knees now. Okay, fine. What will happen now if the dancer does not bend the knees? Meaning that now the stoppage time now becomes smaller in this case. Now the question will say, will the force now be greater than, smaller than, or equal to the force calculated above in 1.3? The effect of the matter is the stoppage time is smaller according to this one. You are going to use the relationship between the net force and delta T. The two are inversely proportional with the same momentum. Then the two, if this one increases, therefore this one decreases. If this one decreases, this one increases. Therefore now, because the stoppage time is smaller, therefore we expect the net force to increase. And that the first, it will be now greater than. That will be your 1.4. Hopefully you must explain in the next question. Let's hear from that. They say, give reason for the answer in 1.4. If you say it's greater than, why? Now, as I have said, there are how many points? There are 3 points, 3 marks. Therefore, they need 3 points. Can you see it's 3 marks? The first point will say, now for the same momentum, for the same delta P, for the same change in momentum, momentum in brackets delta P. Remember, why do you say for the same change in momentum? Is because in both cases when the dancer is landing, she will come to a stoppage. So meaning that whether it takes long to stop or takes short time to stop, the effect will be, it will be stopping. She will be stopping. Okay, fine. That is for the same change in momentum. Therefore, according to this relationship, we said the stopping time will be smaller. Stopping time, or someone can talk about the contact time. Contact time will be smaller. Smaller. So the stopping time will be smaller. You will get 2 marks for saying that. So stopping time must be a mark, and then for the same change in momentum, 1 mark. Will be smaller is this one, because now why the stopping time is because not everyone will know that the force is affected by the stopping time or the contact time. That's why if you recognize that the contact time will have an effect on the force, then you must be credited for mentioning the stopping time. Then it will be smaller, then also that one will be another mark to credit that knowledge. I think the question was relatively very straightforward. I will also search and do some other questions that are similar and that are working with momentum, impulse, and change in momentum. Hopefully our next stop will be the conservation now. Thanks a lot. Until next time.